So this is a review of LB02A process calibrator. So it comes with this nice box, and I suggest do not throw away this box because we have carrying case, we have very nice quality crocodile wires, charger, and tester itself, user manual in Chinese and English, and also how to measure thermocouples instruction. So why I say do not throw away this box, because you cannot fit to this case charger, it will not close, and you cannot fit crocodile wires, but they also will not fit in this case. So kinda barely, but yeah, it will not fit. Imagine you have a multimeter case, and in this multimeter case your probe wires not fitting. So to turn it on, we will press power on push button, and it has this adjustment push buttons on top. So these two up, down, kind of fine tuning. These are more rough adjustment. What I mean, if we select voltage mode, right now it's in output mode, okay, arrow like that. So we can go up by 100 millivolts, and we can here with these rough adjustment push buttons we can go 1 volt up, 1 volt down. Now we can go up to maximum 11 volts. Now if you want a very specific voltage, you can press function button, and here is set point value. In function mode, these all push buttons have secondary use. Let's say hertz push button now delete, yes, and on all of these are numbers, but it's also not great because on dark gray background they put black numbers, so it's kind of hard to see. Oh, okay, I delete set point and I enter, let's say, 7.77, and I press enter. So right now we have specific voltage. We can go out of function mode by pressing again function mode. So right now we outputting, we are sourcing 7.7 volts. Now if we want to measure, we press voltage again. You see this arrow goes to the left side. So right now we inputting voltage. So yeah, let's use it in actual process calibration. Let's talk quickly about charging this unit. So it comes with this charger, 100 volts AC to 240 volts AC, and it outputs 5 volts, 1 amp. Now this unit has 2200 milliampere battery, and we are charging with 1 amp. So it's slow, but it's safe. But what I don't like it, we don't have any indication. This is not charged, this is charging, this is right now charged, nothing. There is no LED, there is nothing. Here we can see kinda, I was thinking that it was a charging LED, it actually resets the program. So yeah, if your unit working fine, do not press this. Now it has USB-C charging port. It would be Well, in this case, I think it would be better to have something like this, okay? Right now it's drawing 210, 190, so we're seeing it's charging or not. Now regarding the unit screen brightness, okay, in my opinion, it's too bright, and you cannot turn off this backlight brightness. So for example, I have here my Fluke multimeter. Look at the brightness. This is plenty in all situations. This is well, it is very good visible from all the angles you can think of. You can actually use it as a flashlight at this point. And you know, this backlight draws battery, so it all depends on what you prefer. So right now we are in voltage measuring mode, and sure, we can just measure voltage. Right now I connect it to my power supply. Okay, so I will output from my power supply exactly 10 volts, and it shows, you know, 10 volts. It has another cool thing, but to show it I need to kinda hold it like that, because the screen is too bright. It's very hard to make a video with this. So if we press function button, we go to this kind of scaling menu, and let's say we have in our factory some sort of a sensor, pressure sensor, that sends signal. Then pressure is 0, it sends 0 volt signal. Then pressure is 20, it sends 10 volt signal. Okay, I'm simulating this sensor with my bench power supply, but here we can actually write this scaling. So we can change voltage high limit, so I change it to 10, and we can change voltage low, so I change that to 0, and we can change scaling, so I change it this count high ch to 20. So you can change scaling here. So okay, my scaling here, low level 0 bars, high level 20 bars. And right now I am providing 10 volts, so as you can see, it counts 20. If I go with my bench power supply to 0, okay, it counts 0, so that is correct. Right now I will go with my bench power supply in the middle of the range, 5. It should show 10. And if we go back from function mode, as you can see, it's sourcing, it's getting voltage 4.998, so it's, you know, in my book this is 5 volts, but in function it shows 9, so it's kind of lacking resolution here. Okay, so another cool thing is if we go back from function mode, right now we are in voltage measuring mode. I will press voltage button again. Right now we are in voltage sourcing mode. Yes. So we are outputting voltage. It can output from 0 to 11 volts. So it's specifically this voltage range for PLCs that have 0 to 5 or 0 to 10 volts analog input channels. So right now I will connect this crocodile wire to my actual analog input card, and we can just scroll by 100 milliampere up and down, or we can just go here by 1 volt. Here is basically the program, and this channel is also has the same scale pressure. I'm imitating with this device sensor, because let's say we have a situation where operator comes to work, he sees in HMI it shows 5 bars, okay, but actually there is no pressure. Valves closed, pipe is disconnected, and on manual manometer it shows 0 bars, but HMI shows 5. So where is the problem? So we hook up this process calibrator and we can simulate signal. Okay, let's say we simulate 0 volts, so our pressure 0. We simulate 5 volts, so our pressure on HMI 10 bars. Okay, let's go to 11. It goes to 22 bars. It goes outside the range. We can sweep all the range and check if this corresponds or not. Yes, because right now we are outputting 10 volts, we're getting 20 bars, so that means it's not our program. So we with this device very quickly can diagnose in which way to go and fix the issue. And also, as I shown, we go to 11, so we go to overflow mode, over the limit. So we can simulate this for a short period of time. We will not damage analog input card. We can actually, with this also we can check alarms on our HMI. Okay, it will show alarm, it will stop process, it will work in an emergency case or not. So this is very useful. Now we are in milliampere input mode. These crocodile wires, we don't have anything, we don't have voltage on these wires. Well, at this point I can only simulate something on my power supply. I provide from my power supply to... So you see, you can measure milliamperes. So let's say you have sensor, it's drifting, it's not drifting, what kind of signal it gives. Yes? So you can check that. And if you press an function button, we can, in input mode, we can also, as in voltage mode, everything the same, we can enter the scale. Just right now the scale not from 0 to 10 volts, but from 4 milliamperes to 20 milliamperes. So 4 milliamperes will be 0, and 20 milliamperes, let's set also to, let's say, 20 bars. Enter, and yeah, we can simulate that again. So as you can see, we're receiving 7.4. I'm just using resistor, it drifts, it actually goes hot, counting only value at 3. This is kinda, we don't have a resolution here. So it's kinda useful, kinda not useful. Okay, if there would be resolution, then yeah, that would be great. So again, if we press milliampere push button again, we are right now in sourcing mode. So we are outputting around 24 volts, and we can set what kind of current we are outputting. Okay, so I connected these wires to my analog input card. Means we have 4 milliamperes. That means we have 0 bar pressure. If we will have 20 milliampere, we will have 20 bar pressure. So again, same situation as with voltage. We can diagnose if there is issue, where the issue is, in PLC, in analog input card, or in virus or in sensor. So right now I will jump to 8 milliamperes. I will go to 12. 12 is exactly in the middle. So as you can see, we are seeing 9.99. So yeah, 10 works fine. We go to 75%. And we can go to 20. It kind of ramps up. It doesn't jump straight to this, let's say from 16 milliamperes to 20. It kind of ramps up. But again, we can, for short period of time, do a crash test, you know, see if we will get alarm, if our system will work in this condition. So we can test our system with this. And if we press this arrow left, it will go to program 3. So it will ramp up and then it will ramp down. It will reach high limit and then goes to low limit. And with this function button we can kind of set this CT time, meaning ramp up and ramp down time. So right now it's 16. I, let's say, want to change it. I delete the value and I will change it to 20. I will enter it. And then there is this WT. That means when set point high limit or low limit reached, how long it will stay there. So I will set it also to 20 seconds. And we can change millivolt high limit, so right now 20, and millivolt low limit, right now 4. So we are simulating system, okay, from 4 to 20 milliamperes. Your sensor could be from 0 to 20 milliamperes, so there is no issue. You can delete it and put here 0. But my system from 4 to 20, so I will enter set point 4. So if we go back from function, as you can see, it goes ramp up and ramp down. Actually, we have trend here, so we can see how it actually works. As you can see, it goes ramp up to 20 bars. It's staying there. And then it drops. But again, it kind of has all small issues, because this CT time is set to 20 and WT time also set to 20. But this doesn't correspond to reality, you know. When the high limit reached or low limit reached, it's actually staying there not 20 seconds, but more like 5. So these timers actually don't work properly, but still this sweeping could be useful. Okay, let's go. There is a program 2, so it's kind of a little bit different. From the low limit it jumps to 20 millivolts and then stays there for set point time and then slowly ramps down. So as you can see, it's a little bit different. And then we will have program 1. So it's kind of very similar to program 2, but it's in reverse. So basically it ramps up slowly to high limit and then stay there for set point time and then drops to low limit and starts again. And we can, again, we can go to function and we can change settings here, but in my unit these settings actually doesn't correspond. Look here, it didn't even raise it to 20. I don't know what was that, but right now it's kind of working. VT time again 20 seconds, but it will not take 20 seconds. It's more like 5 and then drops. And right now I will disconnect cable. Also, it has sync mode. It all depends what kind of mode you need to diagnose your system. So it has sync mode and source mode. Yes. So, but my tester has issue because right now after I was in the sync mode, I pressed arrow and that's it. You know, blank screen. I can go through all the buttons and it doesn't work, so screen is gone. So yeah, I actually reported that to BrightWin and they agreed to send replacement unit. I believe this could be hardware issue. Okay, so let's jump from milliampere mode to 24 volts mode. So what is this? This mode only has output mode, okay? It doesn't have anything else, only outputting. So we can output 24 volts, and if we go to function, again, same story. We enter, let's say, we will connect sensor from 0 to 20 milliamps, and we will say, I don't know, when 20 milliamps, value should be 1600, yes, and when 4 milliamperes, maybe value could be 650. So this is actual values of pyrometer. So we have, I'm working with, so, but when we measure actually what we have here, so we don't have 24 volts on these leads, we only have 22. So there is that, and right now at this moment I don't have. Well, I can again simulate. This is around 2 kilo ohm resistor. So we will simulate sensor. This is our sensor right now. Yes. So we are getting 9.5 milliamps. And it shows, I think this is correct actually right now. So if you have a big low level in hundreds and big high level also in hundreds or in thousand, this counting will work fine. But if you measuring from 0 to 20 bars, let's say, well, you could actually enter from 0 to 200, so you will have a little bit better resolution here, yes. This works fine. Don't have actual device to test this, but this works. And if you go to from function button back to our main screen, we have Hertz mode. And if we press it again, we can measure Hertz. So right now I have on my oscilloscope probe testing place where you put your probes and you kind of test them. I know that I have 1 kilohertz. So yeah, it shows 1 kilohertz. Yeah, and we can actually go press Hertz mode. So this is frequency output mode. And we can use this as a signal generator. I will not go through all the range, yes. I tested with my scope. Yeah, it's fine. It's, you know, it's working fine. It's accurate, most importantly. So right now we are in Hertz mode. Let's jump to millivolt and thermocouple mode. We press this, and right now we are in input mode, and we can scroll with these arrows and change what kind of, well, basically thermocouple we want to measure. So right now I have this K-type thermocouple with my fluke, temperature 26.8 Celsius. We can remove this thermocouple and we can test it with this process calibrator. But you know, it shows too much. Why it doing this? It doesn't show correctly, right? This is because you need to enter cold junction value here. So you press function, and this is right now set to automatic cold junction. So we need to go to CHM, manual cold junction, and enter what we measured with that fluke multimeter, 26.8. We enter it, so this is reference point. So right now value is more or less the same, yes? So, because when you measuring thermocouples, basically, it has inside its own thermocouple. And when this device is basically powered on, temperature rises inside this device. Components heat up, let's say capacitors, inductors, and so on. So it kind of drifts with the temperature. Don't expect it to be like a laboratory level device. Scene value is exactly the same from this to this. In measuring side where you actually want to measure thermocouples, what I suggest to do, you turn it off and leave it there for 2 hours. It will be the same temperature as ambient temperature. Then you measure with your another measuring device ambient temperature, and you enter here this value in cold junction, manual cold junction. So it will be a reference point, and you will have more precise measurement. Right now in thermocouple mode, we press it again. Right now we are in output mode. Yes, so let's say that this is not a multimeter, but this is analog thermocouple input card. Yes, we're measuring on this analog input millivolts. And we need to enter a cold junction 26. Basically, this is ambient temperature. So you can use automatic cold junction, but in this case it will be 31 value, so that is way outside the range, and you will have bad reading. So yeah, always select manual cold junction. And if we go to basically main menu, so right now I'm in this multimeter thermocouple mode. I'm using just regular multimeter leads, and I connect them here. So imagine this is analog input card, yes? We raise it to 100 degrees, so here is the problem, okay? It shows 100, but I selected the wrong thermocouple type. This supports K-type, so we need to find K-type, okay? So we are outputting from this device 100 degrees Celsius signal. This shows 100.4. Let's go to 200. So yeah, very similar. Let's jump to 300. Let's jump to, I don't know, 800. So we are starting to drift right now, you know. So again, don't expect it to be laboratory device, because it's not. But for, let's say, floor electrician, he only needs to make sense of what's going on, just sanity check, okay? Because he can go completely insane by troubleshooting things, yes? So this could really help. And one more thing regarding this PT100, if we go to function, we have this wire, basically compensation for wire resistance. Let's say our thermocouple is connecting to the device, and then it goes to wire, let's say 20 meters of wire. So we disconnect this wire from thermocouple, short it out, measure resistance of cable itself, and then you have this. It usually should be, well, a few ohms, yes, resistance. If cable is good, not damaged, it should not be a lot of ohms, yes, resistance. So we can go to function mode and we can enter this resistance, and it will be subtracted from when measuring temperature. When a 3-wire thermocouple is connected to analog input card, this is exactly what third wire is doing, measuring wire resistance. So right now we have 657 Celsius temperature, but if we enter value, let's say 2 ohms of resistance inside our wires, and I enter it, so we will have 650 C. I don't know if this can change to Fahrenheit, I don't see that. This is only in Celsius. Well, sucks for Americans, but it's good for me. So again, I raised ISO on my camera. We will not talk about the functions, because we already go through all of them. By the way, when you go to function mode, here on power on, power off button, there is plus and minus sign. Because especially when you in temperature mode, when you enter simulate temperature, yes, so you could simulate negative temperatures. I think this is good device and very accurate. I get why many people on YouTube using it to measure multimeters. I get it, because this is very accurate. It comes from factory calibrated. Yeah, but it could be better, obviously. Everything could be better, okay? So yeah, if you like it, like. If you don't like it, dislike. And I see you on the next one.